let's discuss the Soroban state of mind, specifically when it comes to storage and preserving things in the ledger. So as I open this up, I want to hide my face and then focus on the code again. All right, perfect. So we're back to a brand new project. I think we should rename this to state. We're working on the state on the Soroban state. Okay. So sooner or later, every developer finds themselves in a situation where their application is not working as expected. I would say raise your hand if that happened to you, but I can't see you. So I assume everyone's had this problem. And we all know the techniques of how to solve these things, like unit testing or logging intermittent values. Using breakpoints is a cool way to inspect stack frames and so forth. But unfortunately, smart contract developers often don't have a rapid workflow for finding bugs or faults in their contracts. And this leaves them with the only option of, hey, I want to test something out. Well, what do? I take the current code for the contract that I have, and I either one of two options. I deploy this to the test net of your blockchain that you're working on, and I test it against the wallet. And that's going to be, if you're very efficient, under a minute, or it could take a little longer. Or your second option, if the blockchain is well equipped for developers, let's say, you can probably deploy to a local Docker running instance. So that's all fine and dandy, but there's a limit, and folks, I guess, tend to not test as much as they're used to because of all the hurdles. And so Soroban takes this challenge head on by providing a guest environment right in the SDK. So you'll be able to see in the documentation, if you follow along this path, where you write a contract and immediately write a unit test for a function. And this is using your regular Rust cargo unit tests. With useSoroban.app, I leverage that functionality of an environment to provide features to rapidly test your contracts. So right here, we're gonna explore state, because let's face it, if we're writing hello world, probably bugs won't affect anything too much. If we're dealing with state, then bugs all of a sudden become an issue. All right, so let's begin. How do we store something on the ledger? We're going to head and start with the same NoSTD, so we're not going to import the standard library. We're going to use the critical elements like contract, implementation, and environment within, and let's grab a symbol as well from the SDK. And we're going to declare another contract, okay? And then we're going to implement this contract with a couple of functions. Let's declare this the proper way, contract implementation. All right, so what do we want to test to sort of showcase this? Well, first, let's compile often, right? Never too often to compile. We're going to have some data in the storage on the ledger, and we're going to save and retrieve that data. So we're going to have a couple of functions. So let's declare save as the one that will put data into the ledger, and we're going to store a number. It's going to be U32. Now, save is going to return the same number, just for the sake of it, I guess. And we're going to load a number environment, and it's going to return that number. So it's essentially save and load two functions for this contract. Let's compile this again, make sure nothing breaks. Oh, okay. Well, I guess I compiled it a little too early. Let's return some value here. Oops. Okay. So we have something of an issue. If I remove this, let's make sure this compiles again. Quickly back out of this. Oh, we don't need to back out of this. We're just not returning a value for. Should have trusted the Rust compiler errors. All right, so we call save. It takes in a number. And by the way, this is one of those nice abstractions that you get with an environment like usorabon.app. Let's say a function takes in some arguments, right? In this case, it takes in a number argument. That's a U32. Well, we have a nice modal that we can input our number, click confirm, and that's going to call our function. As far as integrating into Sorabon, there's another nice feature that's part of the, I guess, Sorabon contract specification. So when you compile the contract, there's some amount of that byte code that's compiled allocated for specifications. So let's say save something, or rather save a number to the ledger. Okay, let's compile this again. We can see that the modal now incorporates our comment for that function to describe what exactly this number does, or what exactly this function does. So we're going to click confirm, and let's add another specification here, or the docs for this function. Load a number from the ledger. Compile this again, and oh, it doesn't take any arguments. It's not going to display that modal. That's fine. All right, let's return the number as our first exercise. So it's going to be U32 and 42. We get 42 in the console here. And right, so now the magic part. How do we take the number that we provided in our modal here and put it into storage? Well, we need a certain key, something to store it under. And for that, we're going to declare a constant. And it's going to be a symbol value. So that's why I imported symbol. And it's going to be, I'm not original with names under these circumstances, so I'm just going to use storage. And over here, we're going to take the same environment that we've used before for logging, and we're going to reference storage. Okay. Let's compile this. Not the error I was expecting. So storage is a method, not a field, as we can see inside of this error message. We can go ahead and inspect what exactly storage is in the documentation. And let's see exactly how to use it. So we can see that there is a set function under storage. It takes a key and a value. Okay. So with this new knowledge here, since this is a method, not a field, we're going to call this. And since we observe that it has a public function set, we're going to call that set function to store what we're storing. So we're going to provide storage as the key, right? And we're going to provide number that we're storing, or the value. Have this. So save 42. Confirm. All right. How do we know that we did store this correctly? Well, that's why we have this load function here. And how do we retrieve something, right? We used set to store it. How do we retrieve it? Well, we can go back to the documentation real quick and see that there is a get function associated with storage, and it returns an option that's a result that potentially has that value. So there's you'll see that there's some unwrapping that needs to happen. Cool. So we go ahead and reference that same storage, call that same storage, and call the get method, and we want to get the value under storage, the key. So what do we get? We get an error because we're trying to return a U32. So let's return a U32. Now we get another error that says we want to have a U32, but we get an option. So whenever we're getting a value from storage on Soroban in a Soroban contract, we don't know whether the value is there, and we don't know whether that value is the value that we're going to return. In this case, a U32, or it could be a symbol. We just don't know. So we can go ahead and unwrap this option and see if that works. Well, then there's the question of it returning a result. So at this point, we unwrap the option. We're sure that there's a value there, but we're not sure whether that value is a U32 value. So we can do clever unwrapping here, but I'm just going to do a silly unwrapping. So it panics if it's not a U32. And let's compile this again. So let's go ahead and save 111 and load. Okay. So we just put a number onto the ledger under a specific key, and we retrieved that number from the ledger. We're going to an experiment with 420 and load the value, do something else. It works. Okay, so there's a complication that I want to implement here, and it's a little bit different from what we did during Paris Blockchain Week. This is something that Tomer told me to do. And so I'm just going to see if this works. If it doesn't, well, hey, this is a demo. These things break. So here's the gist. I want to store a number for a specific account. So I want to store numbers under accounts. I just don't want to store a single number. I want to store as many numbers as I have accounts. So we're going to modify this save function here a little bit. We're going to take in a user argument or a parameter that's called user. That's type address. So address refers to any valid blockchain address on the Stellar blockchain. And then we're going to take in a number. We're going to return the same value. And let's just see what this does. So if I call save, I'm greeted with this second field here. So in uSoroban, this modal expands to however many arguments that your function takes. And there's another cool abstraction here. When dealing with accounts on the blockchain, it can be like really tricky for someone just getting started, right? How do I know how to generate one? Do I need the private or the secret key here? That's a lot for someone that's into JavaScript or something. So for that reason, uSoroban.app completely abstracts away interactions with accounts by using just regular names. So how many users does the system have? It has 3 users, Alex, Bart, and Callie. You can select either one, and that in the background abstracts it away into a specific address within the current environment, which is running in your browser. All right, so we select Alex 1. So nothing happened really. We just have a parameter that we're calling this function with, but we're not using it yet. So let's try and use this. Okay, so under storage, instead of putting everything into the same key, under the same key, let's try and use user. Okay, so let's compile this thing. It compiled. And let's call Alex and let's do 10. Okay, so that sort of kind of worked, but how do we sort of debug this, right? We can probably do a log here, although maybe we should just use the load function. Okay, I'll just do the load function here. So when loading previously, we only had one key, and we have any number of keys that correspond to each user. So instead of using storage, we're going to use user. Okay. So here's an experiment. So we saved. I think we saved. Let's save 10 under Alex again. So let's load Alex. Oh, we got a 10. So that worked. Let's try Bart. It trapped. Okay, so the trap means that the value doesn't exist, but we explicitly tell this thing to unwrap, 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 not caring about the underlying value. So we can go ahead and sort of test this out. So here's this log macro that we used before. And call this with an arrow just to have some string value in there. And let's see what that returns. We probably need to do some matching here. Take out this. Okay. Now for the type, I think I'm going a little over the description here, but the point being is that we can store values under whatever key that we want, and the key can be anything. In this case, I just displayed that it can be a specific address. So we'll just go over each user. Alex is going to have 11. Bart is going to have 22. And Callie is going to have 33. And let's go ahead and check each one. So Alex, 11. Okay. Callie, 33. And Bart is 22. All right. So that concludes my second demo for the Soroban State of Mind. If anyone wants to, again, experiment with this, please tweet me on Twitter at SorobanDev, and I'll make sure you have access.